Assalamu alaikum, dear students. Welcome to the lecture of the electronics. In this lecture, we will discuss about the diodes. What are the diodes and what are its symbols? A diode is made from a small piece of semiconductors materials, usually a silicon. Now, the diode is composed of semiconductor and semiconductor separately. It is made of silicon, and in which half is doped as p region and the other half is doped as n region. Mean it is just combination of p region and combination of n region. On the one side we have n-type semiconductor, and the other side we have p-type semiconductors, and depletion region is between. For example, in between two junction we have a depletion region where we have no electrons and no holes, just hills of positive and negative ions, and is connected as like in shown in this figure. In this we have p-type on the left side and n-type semiconductor on the right side, and this is cathodes and this is anode, and this is the our depletion region where there is no charge. Okay, this is known as depletion region. The symbol for the diode is this is the symbol for diodes. This side is p side, this is known as anode, and this other side is known as cathode, which is negative polarity. Actually, this is positive and this is negative. Then another important term comes, what is forward bias and what is reverse bias. Okay, there are two ways to connect this diode into circuit. In the forward bias, we connect the positive P region with the positive terminal of the batteries, and the N region is connected with the negative side of the batteries. In this, what actually happen? The diode is to bias a diode, you must apply a DC voltage. Like for example, this is the battery in a forward biasing condition that allow the current to p-n junction. Mean we have n region, electron in n region and hole in p region, and when we applied a bias voltage, mean this n is connected with negative and this p is connected with positive. This n here electron will repel these electrons, and it will force these electrons to go to this region, because this negative and negative will repel each other, and similarly this positive and positive will repel each other. Means all the electron will comes in this region, and this will try to minimize this depletion region. Okay, if we increase this bias voltage, this bias voltage will compel these electron to go from this region to this, because these electron cannot go in this direction because of the same polarity, and you know that negative and negative repel each other, so electron will not come in this direction, it will go in this direction. The resistor, we have connected a resistor that limit the forward current to value that will not damage the diode. It means it will not it will just limit the current to a certain value, which is the, for example, the diode can sustain. And second requirement is that the first requirement for the conduction of the current is p type should be connected with the positive terminal and n type should be connected with the negative terminal. And second requirement is that the bias voltage must be greater than the barrier potential. We have a hill of positive charge on this side and hill of negative charge on this side. Here is the electric field, and it contains some potential which does not allow the electron to go from n region to p region. The potential barrier potential mean this is just like hurdle which does not permit electron from going to n region to p region. This is known the barrier potential, and this is because of the hill of the positive charge and the negative charge. And the second requirement of conduction of electron, conduction of current through diode is that this voltage should be greater than this potential. This because if we increase this potential, this will force the electron to cross this barrier like this. If we have hill, and if we have if give some energy this particle, this will cross this hill. Otherwise, this particle will come back. So this applied voltage should be greater than this barrier potential that exists between the two regions. Okay, So what will happen when the diode is in forward bias? When diode is in forward bias, electron will cross this region from N to P region, and this will conduct current in this circuit, and that the flow of free electron is called electron current. The negative side of the source will provide continuous flow of electron through the external connection. Okay, in this forward bias we will have a maximum current in the order of milliampere as we increase the voltage. So for the next, this is the just diagram in which electron are crossing the this depletion region, and the thickness of the depletion region is going to be decreased, and so therefore electrons are easily able to cross this junction and constituting the current in the circuit. Okay, the second one is reverse bias. This is the effect of the forward bias on the depletion region, as we have previously discussed that in the forward bias, the depletion, this is when there is no biasing, there is no applied voltage, this thickness, this region is greater, and when we apply, so effect of forward bias will be that we have depletion region when there was no biasing. When we applied the voltage, the thickness of this region was decreased. So the fact is that when we apply the voltage, it decreases the thickness of this depletion region. Okay, in the next, the effect of the barrier potential during forward bias. Recall that electric field between the positive and negative ion in the depletion region contained mean we have a barrier potential. We have a hill of positive charge here and hill of negative charge here, that that does not permit the electron to go from this region to this region in this direction. So we have some barrier potential. For example, for silicon it is 0.7 volt, and for silicon we have 0.7 volt, and for germanium we have 0.3 volt. That depend upon the for example, here we have discussed the energy loss result in voltage drop across the PN junction equal to 0.7 volt, and similarly additional small voltage across the P energy due to internal resistance of the material. So if we go reverse bias, in reverse bias we will do that in the P side will be connected with the negative side of the batteries, and N side will be connected with the positive side of the battery. Reverse bias is the condition that essentially prevent current through the diode. Actually the depletion region is going to be widened because this electron at this point will be attracted by this positive side of the battery, and similarly hole in this will be attracted by the negative side of this, because hole is always attracted by this and electron is attracted by positive. So this, the thickness of this depletion region will be increased, and no current will constitute, but very small current will be constituted because of the minority carrier. Because if we have a hole are minority carrier and electron are majority carrier. Here we have a number of electron because this is n-type region, and a few hole, and here similarly we have electron in minority carrier, electron will be in less number, and hole will be in majority. So you know that this is a hole, these hole will be repelled by this positive battery. So these, and similarly these electron will be repelled with this negative battery. When we increase the voltage of this bias, so these minority electron will try to overcome this, but a rare chance that these electron, because electron are very less in number, so it will be difficult for them to go to cross this very large thickness, for large barrier potential, to go from this region P region to N region, and very small current of micro ampere order constitute in the circuit. So in reverse bias we have current, but that current is because of the leakage of current. This is known as leakage of current, because that minority charge carrier cross from, for example, electron which cross P region to N region, and these electrons are very less in number. Therefore these are actually leaking from one region to other. Here you can see that the extremely small reverse current that exists in reverse bias after the so the transistor current dies out caused by minority carrier and region. Okay, so in the next, a reverse breakdown. When you will increase the reverse bias voltage, for example, you increase this reverse bias voltage, normally the reverse current is so small that it can be neglected. However, if we increase the reverse bias voltage, it increase to value called the breakdown voltage, that reverse current will drastically increase. So if we, for example, plot a graph between current that is in microampere order and voltage, for example, here we have voltage and current, so this current will shoot out at certain value of reverse voltage. For example, this is voltage, this axis for voltage and this axis for current in microampere order. So as you increase the reverse voltage, so at some point, this is known as break, this will this whole region will be at this potential, our current will be drastically increased and suddenly it will give us maximum deflection of galvanometer, means show that this our region, our diode will break down and maximum current will show from the circuits. So these are the little bit discussion about diodes and its two situations. The first case was forward bias and the second was a reverse bias. A reverse bias. In the forward bias, we connect positive P type of the PN junction with the positive and N type with the negative. And the reverse bias, P type with the negative terminal, N type with the in this we have smaller gap of depletion region, in this we have larger gap of depletion region. So it is in this current flow due to minority carrier, in reverse bias, and the forward bias current flow due to majority charge carrier. And in the forward bias, current is order of milliampere, and in the reverse bias, current is in the order of microampere. Okay, so I will stop at this point and inshallah meet in the next lecture.